We are going to learn today about Kirchhoff's laws. That's what we're doing. What can you tell me about voltage, current, and resistance? What say about those three?
Voltage equal to current times resistance.
Very good, Sherry. Thank you. V equals IR. Whose law is this? Ohm's. This one is Ohm's law. Good guess though, Galen. So that's Ohm's law. That's always true. So the voltage drop across the resistor is equal to the current in the resistor times resistance. And you can use really just that to solve most basic circuits. But then every once in a while you come across one where you're not sure which way the current is going to end up going. And so I'm just going to give you this example and start here. We'll just start with a problem. So jot this down in here. What do you notice about this circuit? So there's two cells. So it's called a two-source circuit, or multiple source circuit. By the way, this is 9 volts. This is 22. Bless you. This is 15. And this is 6 volts. Talk amongst yourselves and decide which way current is going in that loop. Oh, do you guys know this? The cell has a long side and a short side. Which side is positive? The long side is positive, and the short side is negative. So we now know that electrons actually go out that way, but current will come out of the battery going this way, right? Okay, where do you think it goes from there? Into the middle? Maybe it goes that way? It splits? Part of it goes down here and part of it goes there? Okay. Let's see. It definitely is going to go this way, right? What's the question?
Which way is the circuit going?
Yeah, which way is it going in the middle? So let's just pick. We actually don't know in this middle line if the current is going to the right or to the left. We just don't know. We're pretty sure because this is pushing this way and that one's pushing that way. So we're pretty sure it's going to go around the loop like this, but we don't know which way. But we just pick. So let's just say it's going to go that way and that way. Now this gets a little tricksy because you have a 9 volt and a 6 volt. So you don't really know if the voltage drop here is 9 or 6 or 15 or you don't know what it is, right? So you have to add things up. So there was this bloke by the name of Kirchhoff. And Kirchhoff made 2 laws. And we have always found them to be true. Kirchhoff's first law is called the loop law. And basically it says that around any loop in a circuit, the voltage gains will be equal to the voltage drops. So the total change in voltage is 0. It's basically the conservation of energy. So we'll just write this. Total voltage change any loop is 0. So if you add up all the voltage changes, you're going to get 0. And the other law is called junction law. So first of all, what is a junction? I don't know. What part of this circuit do you think is a junction? Count.
When it branches off the corner.
Good. So this right here is a junction. How many junctions are in this circuit? 2. Good. Do you think this law has to do with current or voltage? Yeah, this one is to do with current. If you had to guess, what do you think it says? Say that again. Oh, okay, yeah, that's a good thought. It'll head towards an area of less resistance for sure. So the law has to do with the total going in and the total going out. What would you say about the total current going in compared with the total current going out? The same, exactly. So this says total current, which we call I, and I'll just say, going into a junction is equal to current going out. Very squeaky. Push this Okay, so these two laws, what they do is they allow us to write some equations about the circuit. Does that make sense? Okay, so, do you want to do loop law first or junction law first? Loop law? Okay, let's do loop law. One thing before we start. The current from here, follow my finger. The current from here to here, is it changing? No, it's only going to change when you go past a junction, right? So if it's all on the same line, flowing through the same pathway, the current is the same. So we might say, right here you have I1. That's the current going through this resistor. And we're going to say that that current is going this way. Okay. Did we say we want to do loop law or junction law? Loop, okay. Okay, so when we do our loops, we're gonna decide, oh, by the way, looking at this circuit, how many loops does it have in it? Any other guesses? Callum says 3, and he's right. Where's the third one?
All the way around.
So there's 2 in the middle, and there's 1 all around the outside as well. I think we can probably get away with just doing the 2 inside ones. Let's say that the current in this loop is flowing counterclockwise. Okay, this one's pushing that way. So we would call this loop 1, and I like to write a little number and then do a loop in that direction. And we're gonna say the current here in the 15 ohm resistor, we would call that I2. And it would be going this way. You with me so far? Okay. So for our loop law, we'll make some equations for that. We'll say 1, and it's going this way. So I kind of just label it like that. And we say, let's start at the battery. As you go through the battery, what's happening to the voltage? Going up or going down? Going up. Our trucks are getting loaded in with energy, right? How much energy are they getting in this cell? 9 volts. So we say plus 9 is our voltage gain through the cell. And we carry around here, we come to this resistor. We don't know the voltage change here, but is it going to be a gain or a drop?
Drop.
It's going to be a drop. So we're going to say minus. We don't know how much the voltage is, but we know voltage equals IR. So we say I2 times 15 ohms, or we could say 15 I2. So we say minus 15 I2. I2 is our variable, right? Okay, and then what would you say for this one? Good. Minus 22 I1. It's not an equation yet, right? What is it equal to? 0. So I'll make this really clear over here. All of this should equal 0. That's our first loop. Like that. Okay, you try to jot down the second loop. Go for this one here. Let's see if yours is the same as mine. Two would be the bottom one. I don't think we need to do the outside one in this case. How is it? Now you got to make a decision here, right? You have to decide which way you think the loop is going. Do you think it's going that way or the other way? The battery's pushing this way, right? It doesn't matter actually which way you say the loop is going, but it will change whether your values are positive or negative. Okay, so if there's just one cell in the loop, usually I just go with that cell, but you don't have to. If you went the other way and your cell was pushing against the loop, you would just have to turn that negative. Okay, so let's do it like this. make it go this same direction, because then it will be in line with our cell. And so if you start with your cell for loop 2, let's go in the same direction. And we're going to say 0 equals our good plus 6 volts. And then we really only have one resistor there.
15 I2.
And is this going to be a voltage drop or a voltage gain? It's going to be a voltage drop. So you would make it negative 15, except for the fact that our loop is going this way, and we've said the current is going to the right. That's the opposite direction. So we have to change the sign. So it would be a voltage drop, it would be negative, but it's in the opposite direction, so we're going to make it positive. So we have to say plus 15 I2. Okay. That should raise some alarm bells, but we'll go with it. Okay, let's do the junction law. Let's take a look at, so if you look at this junction here, the current coming down into it is which current? I what? Good. This is I1, it stays the same. So we have I1 coming in, and it's just one line, so we say I1 has to be equal to, and then what would you say? We haven't made another current plus. It's gonna be this one plus that one, right? So we have to make another current. We have to say that this current in this bottom loop is gonna be I3, so I'll write it here. So we have to have I2 plus I3. We could do the other junction too, but it's going to be the same equation, right? It's just 2 and 3 come back together again, go into I1. Okay, so mathy people, are we going to be able to solve these variables?
Yes.
Yeah. How do you know that?
We have 3.
3 equations and 3 variables, so we should be able to solve it. Okay, I'll give you a few minutes to try. I'll make a video for the answer too.